Hi everyone, just wanted to take a minute to talk a little bit about transforming absolute value functions. So what you can see here is I do have my absolute value function written down, and I am actually going to just add a quick little y equals absolute value, just so that way we have it as a nice little reference. I'm going to make that a different color. Okay, so there, our black line will be our parent function, and we're going to do things to it. So we already know a little bit about what a does, right? We know we go like that, it's going to get stretched, and we know if we go below, sorry, if we're between here, right, we're going to compress it. We make it negative, we flip it over, so on and so forth. So that is something we already know. But let's explore the inside here. And just like before, when we were dealing with things on the inside, right? So essentially what this is, the absolute value of x minus h. You know what, why am I doing it that way? Let me rewrite that. Let me just make sure that we're aware f of x. There we go. Okay, so what we're going to do is essentially what we have here written down is that we have f of x equals a times the absolute value of x minus h plus k. And we do need to be careful of this, right? Because this is the minus in here, just like before when we were transforming linear functions. Same thing. So when you have the negative on the inside, that's the same as going to the right, and the positive will go to the left. But anyway, so this is what we're dealing with. And we're going to kind of look at what happens with h and k. So let's start off with k, because I think that's a little bit more visual. Obviously, you add anything, look, what do you think is going to happen? Right? The vertex is going to shift up, right? I add 3.2, and it shifted up 3.2. So now my vertex, after I've done that, is 0, 3.2, right? And if I had shifted it the other way, right now, if I make it negative, now it's going down to negative 3.2, 0, negative 3.2, right? So if I had minus 3.2, we go down. If I had plus 3.2, I go up, right? And if I, made this a slider and actually did the slider component, right, you can see it's going to go up and down. I'm going to have to zoom out, right? So we go up and down between 0 and 10. Or 10 and negative 10, right? So that's all that's changing, right? That is the only component that is changing. I'm going up and down. And you can see that the vertex, the vertical component, the y value is what's changing. The x value has not changed. So let me just pause this. We're going to go back to 0. Right, and so now I'm back on top of my actual, erase that. All right, and now what do you think is going to happen when I'm dealing with my h? Well, if I go to the right, boop, 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 right? So essentially what this is, I would have f of x equals x minus 4.6. So the minus 4.6, it shifts it over to the right, okay? Similarly, if I had plus 4.6, right, what's it going to go? It's going to go the other direction. It's going to go to the left. Oops. Right? So when you have a plus on the inside, you actually go to the left. And when you have a negative on the inside, you go to the right. Okay? So that is just something to be careful of going forward. But ultimately, what does that mean? Well, that means if I shift both h and k, my vertex now is just going to be my new coordinate hk. All right? So the vertex is always going to be hk. All right, the vertex of an absolute value function will be hk. And then from there, after you've plotted the vertex, you would still be dealing with a the same way as possible, right? So, if I make it bigger, it gets compressed, it gets stretched. And if I make it smaller, right, it gets blah, 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 blah. Bigger, stretched, less than 1, compressed. I make it negative, I'm still flipping it over. The rest of the rules still apply. It's just now we're starting from a different location. The other thing to consider too is now my vertex right here over at HK, now my axis of symmetry has moved. When I was just shifting K, it didn't move, right? When I was just shifting K, my axis of symmetry didn't move. My axis of symmetry will only move when I change H, all right? So H would be with the left and right, and that will affect my axis of symmetry. So now my axis of symmetry is always just going to be that line, right? It's always going to be x equals h. That is going to be my axis of symmetry. All right. So if I had, -2, my axis of symmetry is -2, right? But it still follows the same sort of process. If I go over 2 from the axis of symmetry, I know if I go over here, it's going to be the same thing, right? So that's just how this process will work, okay? So let me clear this and let's look at a couple example problems. So if you were given something like this, obviously we don't care about what's happening inside here. We just care about the 3. But we know we have a -3. So what do I have to do? I have to go down 3. All right, and what do I need to do with all the other stuff I got going on? Well, instead of going up 1 over 1, now I'm going up 3 over 1. And you can see whatever's happening on one side is happening on the other side, right? Because it's still being reflected. So that should be right. There we go. Nice shot. Let's look at a new problem. And it didn't keep my... right? I want a more complicated one than that. Let's look at one with both. Okay. Oh, by the way, when you get something like this, right, see where it's on the inside? It doesn't matter if it's on the inside or if it's on the outside. That's the same thing as that. Just a heads up. We got one more. Whatever we get, we get. Oh, that was the first one. All right, well, whatever. We'll do this. +2 on the inside. So when we have +2 on the inside, that means we go to the left. Okay, left 2. Okay, and now we have to change that. So instead of going up 1 over 1, we're going up 2 over 1, right? Okay, but you just need to be careful because you have the plus on the inside, you go to the left, okay? All right, but that's everything you would need to worry about in terms of transformations of absolute value functions. They're relatively straightforward. It's just a matter of making sure you go the right direction with your x. All right, have a great day, everyone.